Thermal systems. This is Unit 1 on force. Subsystem thermal systems. Well, the first thing you need to know about when you talk about forces and you talk about thermal energy, thermal systems, is that temperature difference is the prime mover. In other words, it's temperature difference that makes the energy move. Now, what that means is that you can't have the same temperature if you want energy, thermal energy to move. You have to have two different temperatures. Like, for example, it's cold outside and it's warm in the house. So you're going to have a temperature difference so that the heat is going to flow towards the cold. Okay, so that's what they mean by temperature difference. They can't be the same temperatures. Now, in talking about temperatures, you have what is called Celsius, which is this right here, all right, the C, and you have Fahrenheit. Now, Fahrenheit, the freezing temperature of Fahrenheit, you can probably guess, is 32 degrees Fahrenheit. The boiling point, most people do forget, it's 212 degrees Fahrenheit. In Celsius, it's 0 degrees Celsius is freezing point, and 100 degrees Celsius is boiling point. And they're based on water. Now, the bottom line is they created Fahrenheit. The numbers are not easy to remember. So what they did is they decided they were going to make another one, sometimes called centigrade, centi meaning 100, all right? You have 100 cents, right, in a dollar. You have 100 of these from top to bottom, okay? We today call it Celsius. Basically, what it is they just said, okay, we're going to make 0 is freezing, and we're going to make 100 the boiling, and then we're going to figure out the graduations in between. All right, that's pretty much it. It was to make an easier or more simpler method of recording temperatures. So I talked about temperature difference before. This little thing right here, when you have that triangle, that's actually the Greek letter delta. And when you see that in science and math, it means that you are going to be subtracting or taking the difference in something. T stands for temperature here, and F is final, minus Ti, I is initial. So what you're doing is you're taking the final temperature minus the initial temperature. So if you have a temperature change in the house, like for example, you start at 68 degrees Fahrenheit and you move the thermometer so that it's reading 70 degrees Fahrenheit. All right, the 70 degrees would be your final, and the 68 degrees Fahrenheit would be your initial, and you subtract them and you get to Celsius degrees. All right, difference in the two. So they're just talking about subtracting. Now, what exactly is heat when we talk about heat? Heat is actually, and this is a key word here, energy. How fast the molecules move. If they move faster, you've got more energy. If they move slower, you've got less energy. Remember, we talked about solids, liquids, and gases. Solids have the least amount of motion, where gases have the most amount of motion. Okay, temperature. We think we have a thermometer outside. See, the guy's kind of cold. He's shivering there. What exactly is that? It is the measure of the average energy of motion of the molecules. So it is a measurement. Okay? And when you hear the term insulated, you talk about insulations, being energy efficient today. We talk about, and this is something, insulation. We'll talk about that later on in the year, actually towards the very end. But insulation, okay, what exactly does it do? Well, a general term means to reduce the heat flow. In other words, it doesn't let heat go through it very easily. So when you say something is insulated, that's what it means. Okay, a thermometer. We think of thermometers as usually being glass, and they either have a red substance in them or they have a silvery substance in them. If it's red, it's alcohol. If it's silver, it's mercury. Because mercury is a heavy metal, We don't like to use that these days, and not only that, but you really do have to be careful with mercury. It stays in your body. That's primarily what we've used for measuring. Okay, it's a temperature difference. All right, measuring device that uses a change in some physical property. And you might be saying, well, what physical property? Well, what happens is when it gets cold, it contracts, and when it gets warm, it expands. And that's the physical property that it's really based on. And we use that to indicate temperature change. Okay, and just again to reiterate about the alcohol and the mercury. One thing you have to understand is that thermometers, by today's standards, with technology being what it is really not the best way to measure temperature. And we're going to be studying that. All right, a little bit later on. Okay, I said before, with the temperature scales, they are based on water. Water freezes and it boils. All right, for when you're talking about your Fahrenheit, we're talking about 32 degrees Fahrenheit to 212 degrees Fahrenheit. Celsius, you're talking 0 Celsius to 100 degrees Celsius. Okay, but we live in a world today that we have not converted over totally to Celsius. So what do we have? We have both temperature scales. So that means that you have to be able to convert. Here's one of the conversions here. If you want to convert Fahrenheit to Celsius, all right, and it's very important that you do what's called the order of operations. In other words, you do things in a certain order. All right, whatever your Fahrenheit temperature is, you are going to subtract the 32. Okay, and my suggestion is that when you do this, if depending on what type of calculator that you have, make sure you observe the parentheses. If you do not use the parentheses, then my suggestion to you is make sure you hit equal or enter on your calculator before you multiply by 5/9. Now, if you are not a lover of fractions, all right, here is a conversion that you can use that's fairly close. And you can multiply, instead of multiplying by 5 and then divided by 9, you can just multiply by 0.555. Now, is it important to have those 3 5s? Yes. All right, because if you just hit 0.5, well, that's 1/2. Okay, that would be like 4/8. Now, 4/8 is not 5/9, so you want to try and get as close as you can. So you do need those 3 5s there. Now, the other equation that we have, if you have Celsius and you want to convert to Fahrenheit, what you do is you take the Celsius and you multiply by 9/5, and then you add 32. Okay, again, if you don't like fractions, a way that you can do it. Instead of the 9/5, look over here, 9/5 is equal to 1.8. So what I can do is I can take my Celsius, multiply it by 1.8, get my number, equal, I use parentheses, whichever, plus 32. Okay, and it's usually a good idea to use things that you know. A couple good ones to know, for example, would be the boiling and the freezing temperatures. You can try those. But how about some other ones? We have one coming up here. This isn't the one I was talking about, but I think you'll understand. Okay, in this particular case here, I have 50 degrees Fahrenheit. All right. What if the temperature of 50 degrees Fahrenheit? What is that going to be on the Celsius scale? All right, so I'm going to take my 50 degrees Fahrenheit and I'm going to subtract 32. I get 18. Multiply by 5/9, okay, or that 0.555, and I get 10. All right. So what do I have? I have 50 degrees Fahrenheit equals 10 degrees Celsius. Now, this is the one I was talking about before. 20 degrees Celsius. All right, actually is equal to room temperature. You might think that's surprising, but actually it is. And we're going to take Celsius, and we're going to use this equation right here. So we're going to put 20 in here, multiply it by 9/5, or if you don't like 9/5, we use 1.8. So 20 times 1.8 gives me 36. Add the 32, and I get 68 degrees. All right, and that's 68 degrees Fahrenheit. Now, what does that mean? 20 degrees Celsius equals 68 degrees Fahrenheit. That's actually considered when they say you should set your thermostat at room temperature. That does not mean 70 degrees Fahrenheit. That does not mean 72 degrees Fahrenheit. It's actually 68 degrees Fahrenheit. All right, well, that wraps up talking about temperatures for today. You'll have a worksheet that follows, and I'll talk to you later.